Of the grade 9 academic course. This whole chapter is on solving equations, and by solving equations I mean find x, and by the end you'll certainly see what I mean. I know that you have done solving simple equations in earlier grades, but it's time to get really good at it. Okay, so we want to find x or g or x or m or whatever. First of all, when I say equation, what does it mean? A mathematical statement that says two expressions are equal. So up until now we've dealt with an expression, like 4x plus 1 would be an expression. Now we're saying 4x plus 1 equals 2x minus 5. And by the way, if you ask yourself that very good question of why do I care what x is, as you get into more senior math, or even by the end of this chapter, you start to see lots of applications why we do care. And as a physics teacher, I can tell you there's tons and tons of really important reasons why we care. Maybe this particular expression has no meaning, but if you know how to work with this expression, you'll learn how to work with expressions that are more important. Okay, so what this sentence means is, this is a math sentence, I guess. This equal signs means this whole side equals that. When we're solving or finding x, we're finding what number can we put in for x that would make this expression true. That if 4x plus 1 equals 2x minus 5. What number would x have to be? Okay. If I go too fast, please just stop and pause the tape. So when we say value the solution, that is what I just said, the value of x. I think this one's easier to see. If x plus 2 equals 5, well, what number must x be for this statement to be true? Well, x has to be 3, right? There's nothing else x could be for it, something plus 2 to equal 5. So x equals 3 is what we call the solution. Okay? Opposite operation. So this is the most important thing. It could very well be that up to this time in your math career, you haven't had to use opposite operations. You've always solved equations by what we call inspection. I'm not even really going to talk about inspection. It's not that it's not a valid strategy, but it's not a valid strategy. It's a valid strategy with easy equations. It's not a valid strategy for the types of equations we have to solve in high school math. So, you know, this one, I call it inspection. You just look at that. You don't have to do very much just to know that x equals 3. That's called inspection. Okay, and probably you've done that before. We're going to use opposite operations in grade 9 math, though, and grade 10 math and grade 11 math, and because for sure you will be solving equations is one of the most important things we learn to do in math. Just quickly, if you see the term root, it's a very important concept in grade 10 math. I notice sometimes textbooks or questions will use the term root. It just means solution. There's no difference. Solution, root, it's the same as far as we're concerned. And like I say, in grade 10 math, it's a bigger topic. Okay, so for solving simple equations, the most important thing to know, what you do on the right, meaning on the right side of an equation, of the equal side, you must do on the left side of an an equation. And that just means, you know, for two things to be equal, you can't, if you're going to change, you know, this is the right side of the equation, right? If I'm going to change that 0, for this statement still to be equal, I have to change this one the same. Whatever I do here, I have to do here. Okay? So in this equation, we're looking to, find x. And what does that mean? And again, I know you can do this by inspection. I recognize that. I'm going to show you how to do it with opposite operations, because as equations get bigger, you can't use inspection anymore. It doesn't work. So we want to get x by itself. And how do you do that? You use opposite operations. So just to show you what I mean, because we're subtracting 5, so if I want to get rid of this 5 so I have x by itself, the way that I do it is I add 5 to both sides. That's the opposite operation. Subtract 5, opposite operation is plus 5. And again, if you notice, I'm doing the same things to both sides of the equation. This is the original. I add 5 here, I add 5 here, and that tells me that because minus 5 plus 5 is 0, all I'm left with is just x over here, and 0 plus 5 is 5. And again, with inspection, you know that 5 minus 5 equals 0. It makes sense, right? Just another one. Keep doing a bunch of examples just to get the idea. In this case, where 4x equals 12, the opposite operation to, like 4 and x are multiplied together, the opposite operation is divide. So I want to get x by itself. I divide both sides by 4. And you'll notice 4 divided by 4 is 1. Right? So that means that you end up with just x on this side of the equation, and this becomes 12 divided by 4 is 3. And if you don't believe me, that's true. If you just think about it, 4 times 3 equals 12. Okay? And these are solving simple equations in this chapter, in this section. One more. All right, in this case, we have x divided by 5 equals 6, right? Remember I've told you before that a fraction is just x divided by, so my opposite operation is multiply. So on both sides of the equation, I multiply 5. This 5 and this 5 cancel out, it becomes basically 5 divided by 5, which is 1, and you end up with x equals 30. And again, if you think about the math there, 30 divided by 5 equals 6. All right. So solving simple equations might include a two-step equation. And in this case, it's not just as simple as one opposite operation. We have to take 2 steps. The first step is we call that collecting like terms. And what I mean by that is you get all the x terms together on one side of the equation and all the non-x terms, just the numbers, on the other side of the equation. Okay, that's what I'm writing down here. So that's the first step. Once you do that, then you go back to what we did for a one-step equation using opposite operation. So remember, I want to get all the x terms together and the non-x terms together. So that means this 6 has got to go to this side of the equation. So it's added, so I subtract it from both sides. Okay? The last step then, that leaves me with 2x equals 12, right? Because 6 minus 6 is 0, and 18 minus 6 is 12. And then I use, these two are multiplied together, so I divide both sides by 2. So that this 2 over 2 is 1, and I end up with just x equals 6. Okay, so that's a two-step equation. Another one, this one's really only a one-step equation, but it's just a weirder looking one. I thought I'd put it in here. If you have minus x equals 12, you have to remember that minus x equals minus 1x. Right? And so when you get x by itself, you divide both sides by minus 1, and then you end up with x equals negative 12. Moving on. In this one, again, 2 steps. 3x minus 1 equals 11. So first thing I do is collect like terms. I got to get all the numbers over to the right side of the equation. So I add 1 to each side. Okay, so I add this one and this one. And I end up with 3x equals 12. And then to get x by itself, you divide both sides by 3. X equals 4. Okay, so two-step equations. I think I have one more, a word problem to finish. So we're going to solve basically 2 equations to find a better deal. So Ferd is at the fair. The fair has 2 deals on tickets. In the first deal, you pay $2 for every single ride you go on. And in the second deal, you pay $5 right at the beginning, and then you pay $1 for every ride after that. So if he has $50 to spend on rides and he plans on spending all of it, which one will allow him to take more rides? And so, I wrote down the steps here for you. First thing is you say, okay, I'm going to declare R as the number of rides, and we're going to make an equation. We're going to make an equation for deal 1, and we'll make an equation for deal 2. Then we'll solve each equation for R, and whichever equation gives us a bigger R, bigger number of rides, that's the deal he should take if that's his goal, is to take the most rides. So I'm just going to move this over so that we can see, this is actually deal 2, but in deal 2, let's see how I came up with this equation. He has $50 to spend, and that's got to equal the $5 that he has to pay up front. So this 5 is this 5, and then his dollar per ride, $1 for every ride. Okay? So using $50, and then we're going to solve this equation for R. So opposite operations, I'm going to take this 5 and subtract it because it's added right now. Like when there's a 5 right here, it's like it's a plus 5. Implied is the plus 5 in the front. So you subtract 5 from each side to get 45 equals 1 times R. So that means that if he chooses deal 2, he gets to take 45 rides. Right? Now you might in your head know the answer here then. If it's $50, $2 every ride, you could probably answer the next question without doing the equation, but we're going to do it anyways because sometimes they're not that easy. So for deal number 2, is his $50, and that's got to equal his $2 for every ride because there's no upfront price, right? It's just $2 for every ride he goes on. And so then I want to get R by itself, so you divide both sides by 2. R is multiplied by 2. and it turns out to be that R equals 25. So with $50 to spend, he's better off to take deal 2, so he can go on 45 rides. He only gets to go on 25 rides. Okay, so that's our first lesson on equations. Please make note of any problems you have or questions you have for me to ask in class.